So there's a couple of things you want to do to tune Wireshark for VoIP. The columns need to be modified, so it's really useful and important to have the source and destination port numbers in your columns. You also want to turn on the display raw SIP and then don't show /R/N settings here. So in your preferences, you can go to appearance, layout, columns, and you add some columns here. Source port and destination port are two really useful ones because they show the source port the traffic is coming from and the destination port to which it's going. And then you've also got these in the protocol settings down here on the left, lower in the preferences, you're going to be able to find SIP protocol settings. And there's a couple of options: the display raw text for SIP, and then don't show /R/N. Those are really important settings to use. They make it a lot easier to read. So let me show you how you get there and set those up, at least on my version on a Mac. So we go to the preferences. Got columns here. So I've got source port and destination port. I've already added those. Let me delete one and I'll add it back just to show it to you here. So here I'll call it SRC PORT. And then I pick the type. So this shows what's going to be applied here. And so I want the source port number. And I'm going to use source port unresolved. There's a few different versions of this, but this ensures that it's actually going to show me the number and not the address. So as you can see here, I can't actually see it because my window is too wide. So I can't actually see that until I scroll over and then I see, oh, there's my source port. Well, I can modify that and drag this over here. Put it where I want it to be. The problem here, though, is my source port is not the field I really wanted. For the destination, I really wanted the destination port. So I'll show you another quick way to do this. You can go to, here's a packet, and I've got destination port. I can control click, and I can apply as column. So I've created a new column, destination port, and then I can get rid of one I don't want. So I'll remove this column. So now I've got destination port, and it's really giving me what I want. So once I sort here, if I click on one of these, like source port, it's going to sort by the source port, which is probably almost never what you really want. It's not a very useful sort, and it's not necessarily going to be in chronological order anymore, and you can see how I'm missing a lot of packets when I do so. So you can always click on the number if you've got the frame number. You can click on that and put them back in the proper order. Or depending on how your packet capture works, it may actually be more reliable to click by timestamp, because sometimes you're going to get a capture which is merged, and so the timestamp is going to be a more reliable way to collect this data, to get to this data. As you can see, so in some of these cases, this destination port is blank. Well, that's because the destination port is for TCP. So if I look at this setting again, go to column preferences, it's actually showing me the TCP destination port. So that turns out not to be quite right. What I really want is the destination port unresolved. And I'm going to rename this something a little shorter. And so now anytime I'm using a protocol like TCP or UDP or SCTP, then I'm going to be able to get a source port and a destination port showing up here. So here, this is DNS traffic, and I've got a source port. Now that I really want my destination port right next to the destination here, so that when I've got an IP address, I can get it. Now you see a protocol like ICMP, it has a type, but it doesn't have a port number. And so you don't have any port numbers here displayed for this. But this is super valuable because in SIP and RTP, often a lot of our problems are built around where the traffic is coming from and going to, and what firewall rules or NAT devices are getting in the way. So port numbers really matter a lot. They're really a fundamental thing that we have to look at. And so for troubleshooting VoIP traffic, being able to see the port number is a really important thing to get. You can also see I've got colorization rules here, and I've got a little view. So these packets are colorized according to some rules. I can turn that on or off. And then, but when I turn it on, I get a little bar graph here on this version of Wireshark that shows the colorization of the whole file. So from at the top of the file, I tend to have a lot of green, which is this TCP. And then down at the bottom of the file, I've got these tans, which is all this ARP. That just happens to be because of the way the traffic was recorded and sorted and what was captured there. But even sorted in packet sequence order, I still have a lot of this green section here. So this gives me kind of a preview of the type of data. You can modify these colorization rules and make them do different things. So you can apply the rules that that you want to have on the individual packets and customize them according to the project that you're working on. So the other settings, we'll go in here in the protocols. I'm going to scroll down to SIP. Lots of protocols here that are supported, and this is an open source project, and so anybody can submit new protocol decoders to it. And so the folks who've worked on SIP have worked really hard. There's been a lot of people who've improved the SIP decoder over time. So these settings, display raw SIP and don't show \r\n, these are actually really helpful for decodes, and it's because of this. I'll show you. I'll do a SIP packet. You can just search for SIP with SIP. That if I don't have the raw SIP mode, then I see this, but in order to read individual details, I've got to sometimes decode it and expand these things out. But I find that generally to be a little less useful. But the SIP as raw text basically looks the same way it's going to look in a SIP log. It's effectively the raw text of the SIP message. And so this is typically a lot easier way to read it. Now, it's not perfect for every application. Sometimes even when you're using Wireshark, you want to use the decoded version. So for example, if I wanted to search by call ID, I kind of have to, even though the call ID shows up down here, there are things like applying as a filter to search for this. So if I want to search for other instances of this call ID, that I really need to do in the decoded version at the top and not in the raw text version at the bottom. The raw text version at the bottom, it's going to be sensitive to things like capitalization and spacing, which is not really what I had in mind when I was trying to find all of the instances of a call ID. So in order to properly match, I really want to do my search based on the decoded version, the parsed version at the top. The \r\n prevents it from showing the carriage return new line encoding here, so it just looks like it looks like new lines instead of looking like a sequence of funny characters. Now, one other customization that a lot of people do is they'll hide the packet bytes here. But if we look at the packet bytes, it's kind of cool because you can click on parts of the decode and you can see the corresponding bytes. And if you look here at the end, you can see this \r\n. So the carriage return character is hex 0D. So that's shown right here, that hex 0D character. I'll highlight that for you. And then the line feed character is hex 0A. And so that those two characters, hex 0D and hex 0A, are used to represent the new line character, and that's actually what's specified in the SIP RFC as the new line character to be used, sequence to be used between each of the SIP headers in there. But there's no reason to look at those normally. We normally wouldn't, if you were looking at this file in a normal text editor, you wouldn't see this, or a log file. These would normally be treated as invisible white space. So carriage return line feed, that hex 0D, 0A combination can be safely hidden by the hide \r\n feature in the configuration. So the hiding of packet bytes is that other option I mentioned that's actually usually fairly useful. It helps us to get as much as possible on the display. And so we can go to view and we can just uncheck packet bytes, and so that goes away. You can always get it back when you suspect, oh, I need to see those, when I need to see those individual bytes to see what's something that's going on, whether there's something fishy here, whether maybe, a common thing would be, well, what are these characters at the end? Is there anything after the final \n, \r\n, or maybe your decoder is having trouble with some characters in a caller ID. I've seen this before, where the caller ID is causing some sort of the text in the caller ID, the caller name in particular, is causing some sort of angst for some software that's not ready to handle those characters. And so, for example, if you had an emoji character that showed up in a caller ID, then some systems are really just going to balk at that. They're not going to handle that well. And so, being able to see exactly what those bytes are, be able to see, for example, like the J character here is hex 4A, and then 65, 6E, 6E, 79. You know, those characters, that can be really helpful to be able to decode that, but it's really only in cases where you're dealing with the binary level of the protocol. Unfortunately, in SIP, nearly everything is a printable character, and so we don't have to do that very often. So there's another feature that you can do that makes Wireshark a lot more useful for this kind of work, which is enabling the guessing about RTP. So SIP will be normally processed, and then it will figure out what port numbers are going to be used for RTP, and then it uses those port numbers that it learned from the SIP messages to do highlighting and otherwise to identify RTP. So it's really nice in the fact that if it has the SIP, then it's able to identify whether this particular packet is RTP based on port numbers, and then the content of the packet, of course. But you can actually ask it to try a little harder so that it doesn't have to see every SIP message perfectly to be able to figure out what the UDP is. So there's an option you can go into that will and tell it so that when it sees UDP and it doesn't know what else to do with it, to consider whether this might be RTP. And so you go to Analyze Enabled Protocols and then RTP UDP. And let me show you what that looks like. So Analyze here, we go to Enabled Protocols. We've got a checklist here. These are all the different things that it's going to try to decode. If you theoretically, if you uncheck these boxes, it'll make Wireshark a little faster. But I've never been quite so desperate to spend my time unchecking all these boxes. But the RTP UDP is the one we're looking for. So here I've got RTP and I've got the UDP box checked, and this will make it so that it again tries to match each unknown UDP packet as potentially being an RTP packet. And it's actually really, really fast. This code is written in C, C++, and so it executes really fast to determine whether packets match these particular protocols to do so. But this one is not on by default, so you're going to want to turn this on, and it's going to make it so that Wireshark can decode RTP in a lot of scenarios where you would have to manually override it otherwise. Okay, so I want you to set this up, and then I want you to go through and do this. Well, let's go through this one together here. So what we want to do is pull it up here. So we want to open the file. I've already got that file opened. So we want to hide the packet bytes. So that's the view packet bytes here. So I'll put that in the hiding mode, and then enable raw SIP and disable \r/n. So that would be done in preferences, protocols, SIP. Don't so do display raw text, and then don't show \r/n. So we've got those, and then I'll just to make it fair, show you how I do it, how I can do it. Remove those columns. Now we're going to add the new columns here, and let's see here. Wrong window. Columns. Add a column. Destination, or we'll do source port. Do source port number unresolved. Resolved would normally give you the name of it. So like instead of port 53, it would give you DNS, for example. And then here we want the destination port unresolved. Then we can move these around where we want them to be. And you know what? It doesn't, it looks like it had a bug there. I'm gonna have to add destination port back, or I made a misstep. Destination port unresolved. So I've got my source address, source port, destination port. And what actually has disappeared here is the info column, which is interesting. Looks like a little bit of flakiness in the column editor there. So hopefully you were able to work through that. All right. So, okay. I don't know what you're supposed to write in there. So we're supposed to open another file, AN0103D9. So I'll open up that one here. And sort of by name here. So AN0103D9. Okay, so got it. And then are packets 1, 2, and 3 decoded as RTP? So in my case, they are, because I've already got that turned on. So I can tell they're decoded as RTP because the protocol says RTP in all cases. So yes, they are decoded. Now I'm going to enable the RTP UDP decoding. So enabled protocols, RTP, UDP, got it, turned on. And then determine the codec type used in that call. So what is the codec type, also known as the payload type? So if we look at this particular call, the packet number 1, I can expand it here, and I can see that the payload type is ITUT G.711 PCMU 0. So if you write in all that, that would be perfectly fine. That literal text there. So that would do it. Now the literal payload type number is actually the number 0. That's actually the payload type is 0. It just happens to be in a standardized as payload type G711 MULA, which is listed as PCMU. Okay, so and then Fred Flintstone. All right, so Fred Flintstone is going to submit this.